Welcome to the session today, everybody. My name is Pat Lacey. I am an instructor and curriculum coordinator here at Ken Code Communities, and today's session is going to be the power of local AI. This is a really exciting conversation topic, especially in today's age with the world of free subscriptions and free AI usage slowly going and phasing out to a bit more of the practical cost and power that is being used here. So, as local AI can possibly add in some more, financial reasons and a little bit more of just a different way of thinking about why we would want to use AI in different environments. So let's get into things. First, as a good plug, I always like to mention a bit about our organization right off the top. Ken Code Communities is a nonprofit started in 2016, and we are focused on digital literacy and digital equity. We provide these literacy workshops, similar to these monthly AI webinars that we have here online, and we also hold more in-person, virtual but hands-on courses that cover basic computer training, getting you guys comfortable with the laptops for the first time, and even basic, Microsoft 365 applications and whatnot, all the way up to even software courses, getting into coding. We at Ken Code, kind of baked into the name, we believe that everybody can code and have that digital literacy. So we get into coding and even have AI as part of our courses. So if anybody's interested after this session, we can definitely talk further about that. But let's get into the fun stuff here and why we're all here today. First, what are local AI models? In other sessions, we've broken down AI to kind of the algorithm a little bit more in depth, but today we're really just seeing what these models are as far as the difference in environment. And what I mean by the environment is basically, when most people use AI, you go to ChatGPT, you go to Gemini or Claude or even Copilot, and you're using a AI running on a cloud infrastructure without you even thinking about it. You're on the internet and all of your requests are being sent over the internet, being processed in a big data center somewhere, and then sent back through the internet again. So there's a lot of different things at play there that can make that unwanted. Security, especially if your data that you're asking AI about and then getting the responses back are really important. We want to make sure, that isn't exposed as much as possible. But then just generally, other things like availability and control are really important too here. And this is why mainly we use local AI models. Local AI runs on your personal computer or sometimes even local servers. We'll talk a little bit about what that looks like in a second here. And this makes it so that way it doesn't need to rely on an internet connection. That really improves the availability. Think about all the times where you're on the go, you're maybe like in the middle of nowhere with no cell reception, and you have a question, or maybe you're just not trying to, maybe you have bad internet reception. All of these different things can limit your availability to these tools if they're not local. So that is a big part of just being able to on the go ask a question and get that response. Then control is also a really helpful part of this. I mentioned privacy, so I'm skipping that part, but generally control is important too. Whenever you go to ChatGPT, I always find it very limiting, especially on the free accounts, that you don't have any choice over the models. OpenAI has, so many different models out there that are available. But when you go under a free account and you're, just interacting with the chat app that way, you are only given a strict setting of usage as well as only a strict setting of different models that you're available at that point. So, having this control over what models you have at your availability, and you can delete and upload new ones. You can even train or fine tune new models to be more specifically intelligent in your types of tasks. So when you have the model downloaded on your computer, you have it in your hands and it's a lot more controllable. And sometimes that's good, but very technical at points too. So let's talk a little bit more about why we would want to do this and when, because I definitely know that as we get into this topic, people sometimes think about local AI models as like the replacement instead of more of like filling in the bottom gap, I think, because basically the state of the art models that are out there, OpenAI's GPT 5.5 or Gemini 3.1 or 3.5 Flash, all of these big models that are being pushed out at the state of the art level, they are consisting of trillions of parameters. And when I say parameters, I mean active values in that algorithm that are being changed and kind of holding the intelligence throughout the training process. So a lot of math elements incorporated there, and all of that needs to be incorporated whenever the model is going to create an output. So that's a lot of power. It's a lot of extra calculations that are put towards this model, but it does improve the quality of that output. It does give a better intelligent response because it's so big. There's actually this visual cue that we're looking at here at the bottom of our slide that is a little graph kind of detailing what's known as the AI scaling laws. And essentially, this bar that's color coded here, it's showing the size of the model. And our y-axis, the training loss, as it's labeled here, is basically the performance of the model. So as the models go from 75 million parameters to 10 billion parameters, and we already discussed how state-of-the-art models are even trillions of parameters. That's like 100 times more than 10 billion, which is a crazy thing. You think about millions being a lot, but then million to trillion is another like million scale, if that makes any sense. It's crazy once you get to that level of scaling in this regard. So all that to say, the the performance or this scaling law shows that the performance does have a stopping point. Basically, smaller models only have enough space to hold this level of intelligence. It's kind of like if you think about kind of the classic jokes. People look through somebody's ear and see they got like a tiny brain because that's implying that they're dumb. It's the same thing here, but just generally kind of on the flip side. Our devices have only so much space to hold storage, run applications, and then there's data centers, which are truly just a huge warehouse of computers built to work together and provide that huge level that laptops or modern commercial devices just can't provide. So it makes sense how local models would have less intelligence and the state of the art models that are provided in those data centers are, way past that level of intelligence. It's important that we cover that, but this should not be, the thing that you're taking away as like why you should never use local models. It's just a asterisk to keep in mind that these models aren't going to be able to do everything. Ultimately, keep this idea of having a local mindset more than just trying to replace everything with local AI. Instead, ask what tasks or what things can I do that make sense to be put towards a local model first. As these local models are being developed over time, they are getting smarter and smarter. They are, as we see here, not going to get to that level of state-of-the-art intelligence, but think about how much tasks you do on a daily basis that don't really require your whole focus. There's a lot of intelligence that is just repetitive that you put into action on a day-to-day basis. So if you can kind of take those simpler tasks and build out a local setup, you have a lot more of a kind of an efficient workflow instead of always relying on these massive resources out in the cloud. So I know I threw a lot at you guys with kind of the framing of this and how to approach it when implementing local models. But now let's get into what this actually looks like when you use this on your computer here. And for everybody to have some good common ground, let's talk about the processors that are on your device. So central processing units, most commonly known as a CPU. They're the most common processor. They're on any laptop, any desktop, or sometimes even phones. These is like the brain or the heart of the computer. And generally, it is able to have what are known as a small number of cores. These cores is something that we'll really focus on here in a second. And these are optimized specifically for complex instruction, and it allows the computer to handle this wide, diverse workload across all these different apps that I currently have up right now. I'm running Zoom, I'm running Google Drive, I have my Google Sheets up, I have a couple of other apps running in the background that I probably should have closed before this. All of these things are still being handled by the CPU because of all of this powerful core manipulation here. But let's talk about cores a little bit more of the idea here. Each core is capable of executing instructions provided by these programs, whether it's Zoom, Teams, whatever. And generally, we have multiple cores. We think of cores as kind of like the worker in a factory. If you have one worker, there's only so much that can be done. But if you have multiple workers, it suddenly becomes more of like a warehouse where everybody has a defined role, and it just, speeds up the process in a team working scenario. Also, something that's great here is, kind of think about your team. If you're struggling through something, you have somebody who can help you out. And that's kind of this idea of load balancing. So everybody still has work to do, and we can complete the task a lot faster working as a team there. And so multiple cores is really powerful. Modern CPUs typically have two cores at least to dozens of cores, maybe like 12, 24 at the higher end, even more. But generally, it's a small handful of cores, but they're really powerful to do all of these app interactions on your device. But as time had went on, this is kind of the history moment for this course here, where at the time where we were developing computers and we were getting into a lot more video and gaming requirements for these devices when, there was gaming getting a lot popular, and also, YouTube streaming, all these different virtual video platforms. It creates a lot of processing that needs to happen at a high quality. Nobody likes these very pixely videos, or whenever a video lags out or something like that. And all of that is uh, a heightened requirement within video and gaming, something that we didn't experience before when using other apps on our CPU. And so generally, we found a solution called a GPU. This is a graphics processing unit. And graphics being that main word was the true solution to the required well, the heightened requirements of the video and gaming stuff. And we kind of see it here with these visuals. This is kind of the breakdown or the map of how it looks on your computer here. The CPU has only a few cores, and those are the green boxes that we see there. And then GPUs kind of reorganize their setup to have just so many more cores and a little bit more of like a routing system to get the data to those different spots. But this really optimizes your processing unit, the thing that is actually going to, run the AI model. And it allows for this to do so much more parallel processing. If you think about it, there's now a team of four versus a team of hundreds or thousands. And so obviously you can think about how much work is going to get done between those two teams and how different it is. So CUDA is this interesting tie-in here. CUDA is built by NVIDIA, this main company that has been producing these GPUs. And this, I think, has been the biggest push in the AI technology with utilizing GPUs, is this ability for a programmer to essentially, when they write code, normally they write code that interacts with the CPU because they're writing apps, and it's directly like everything we talked about before. It's going to be processed by the CPU because it can support that wide range of tasks at a fast speed. But AI processing with billions of parameters, all of this math, and we want it to be somewhat real time. We want the responses to be relatively quick and feel like we're actually getting some work done instead of just like word by word, second by second happening. Uh, CUDA allows us to essentially write in our programming ways to route our processing not to the CPU, but offload it to the GPU. And this really allows us to do things like AI training, AI inference, which is, not training, just asking at that level of intelligence a question. And yeah, this really is what powers a lot of our local setups to be so efficient and not be super slow, even slower than what they currently are on our local devices. So I know we're focusing very much on CUDA here, and we're detailing how important it is, but it's important to also think about you are okay even if you don't have an NVIDIA GPU. There are alternatives, though these alternatives aren't as popular. AMD, another high-level GPU creator, they have their own alternative as well as other third-party services. And so this can really open up the world of availability for local solutions on your devices. So I want to get to some cool examples here, but first, let's talk about the limitations, because generally, the limitations are something to think about and kind of find where our Goldilocks position is within the model that we can actually host on our devices. Power consumption is an important thing. If you think about GPUs, they're doing a lot more processing at a lot faster of a time frame. That means that there's just going to be a higher level of power consumption in general. And this is one thing that I think not a lot of people are focusing on as much here, but the environmental impacts, the higher electricity costs, we're really hitting that point where a lot more people are focusing on that. And I think this is an important trade-off that we always need to keep in mind as much as the benefits kind of go hand in hand with the power consumption here. But aside from that, memory bandwidth limitations are the main halt for most people when they talk about local solutions with AI. If you have a laptop and you have a GPU on your laptop, that's great. That's going to allow you to have that parallel processing a lot better than if it was just running on your CPU. But your GPU still has a limitation. Essentially, if I actually go back to this slide over here, I'm not going to break down the chips to a fine detail in this lesson, but generally, what we see here is, the green cores were the main focus within the earlier discussion. But now, if we think about where the data is being stored, we see that there's not really like enough space or not a lot of space if you look at like this space that is taking up of like the green boxes and the other space that's like the L2 cache or DRAM or even those purple boxes in that GPU configuration. Those are the different spaces where memory would be stored on the chip. And so that is a limited space for this big model with billions of parameters to fit into. And there's usually the case that, especially on commercial GPUs that we have in our laptops and other situations, we are limited to this memory that can fit on that GPU chip for it to like efficiently process that data and give you your output in a timely manner. So, having an ability to run a local model doesn't mean that you'll be able to run the same size model as GPT 5.5. We kind of detailed that at the start, but I think this clearly defines why. It's not always this, how much hard drive space you have on your device. It's actually how much space is on the processor to run efficiently. So next is, I think, kind of a two-parter, complexity and compatibility, as well as limited versatility. Um, Generally, you got to be a bit technical to uh, introduce these GPU processors to handle different elements of your work, and a limited versatility basically means that GPUs are really helpful, but they're not good for everything. There's a lot more sequential processing effects for normal apps that we still really rely on CPUs to do for the most part. A GPU is kind of like these other processing units that are coming out nowadays, like TPUs or even quantum processing units. All of these new processing units that are coming out have more specialized uh, directions where they're applied to a specific math problem or an algorithm, and that allows it to be completed faster. than just, oh, this has more processing power for faster results when you're Googling something on a browser. It's a whole lot different. And so I think in general, always see the power of a CPU, but GPUs can be, this kind of additional helper in specific regards and not the best solution for every aspect. So, with that broken down, we've gotten through some computational processors. And I think as we talk about this, it's important to think about how we can access these processors. We mentioned that most devices have a CPU or a GPU, and that's great. That's a good first start. That allows us to run local models on our devices for the most part with no issues. But when it comes to the limitations that we said, your device might not be the best for these local models. So generally, there's two ways of approaching local infrastructure. And what most of us think about initially when we hear local AI is running immediately on the device. Actually, recently, Google has talked about their new Gemma models, which have been talked about as far as being able to run on edge devices, very focused on like things like iPhones or different Android devices, little small computer devices that have even more limitations to the storage and the processors. So these edge devices are kind of what we as users, as humans, interact with at the edge of a network. They're not these routers, they're not the random switches in your company's server rack or whatever. It's the actual device that you type on, or that measures the weather or something. It could be IoT devices, which are a little bit more of these Internet of Things. They can control even your AC, or like smart home assistants are all under that category as well. And yeah, this edge device approach is helpful, but um, you know, it does have that even more limited space to provide that model service. Now, local solutions can also benefit from having somewhat of their own cloud. And when I say cloud here, I think it's important to think about cloud as a network instead of like the internet. There's your local network, and then there's the public network, which is the internet. So basically, your on-premises infrastructure, if you think about like a business, the premises is the building. And so having a server or some sort of large computer that can handle a bigger model, maybe more processing, and to serve, everybody in the office. This could be deployed and allow anybody with a local internet connection to interact with that model. Still doesn't matter if they're not connected to the greater internet, but could allow for a more centralized processing system to then provide the resources to all of these smaller local connected devices. And so it really just depends on your situation, whether you're an independent user or whether you have some really high-powered edge devices, or if you have already an existing server setup or something that you want to provide that can kind of be one source of truth that then serves a huge group of people that might be asking questions to an AI model all at the same time. That takes a lot more than just what one edge device can even provide on itself. So these on-premises infrastructure ideas are definitely some sort of like a cost analysis that you have to go through, seeing if it is truly worth the money there. But if you have a lot of things already set up within a local network facility, you generally can work in these services pretty easily. And then, for even other companies that might want to provide the AI models in a local capacity, but also, let's say you work from home or you take your work home with you or something of that effect. Having it available to the the greater internet, whether it's for public use, whether it's on your website, available to the client, or if it's just for internal use only and it's, hidden away with more of like a login system for employees to utilize over the internet. Having some sort of cloud computing kind of entryway is also a common setup too. So you can very much feel like you're interacting with ChatGPT by then having your own local system set up and exposed or accessible via the internet and public networks as well. So ultimately, I hope you guys see just generally this is more of a talk of like networking a little bit than actual the AI process in here. But this really shows that at any level of your environment, you can find a solution that can facilitate a local model. Though those things have a little bit of trade-offs with the size of the model and, the amount of processing that it can do. But now let's get to the fun stuff. I know I've been talking a lot. We're going to talk about the tool that is accessible to everybody in today's age to run and test out local models. And this is called Ollama. I really like this avatar that they have here, a nice little llama head. This is kind of named similar to the llama models from Meta, and this came around about the same time where Meta was very popular for their local models. They talked about how their way of routing these models to the GPU, and there's actually this famous llama.cpp code file that is mainly what Ollama is working off of. It makes it a whole lot easier to start. We're not going to get into any code here with Ollama, which is great. This is a one command solution, and actually, even more nowadays, they have their own native chat app and still have other solutions for more developer routes using like APIs or CLIs to be more in that developer environment. But even for normal users that just like a chat app, that can be done as well. So we're not going to step through the whole installation here, just to get a good idea of the Ollama's model offerings. Um, Generally, we can go to the website, but I do want to talk a little bit before we do kind of live scrolling here. Um, these model offerings are available and will always update. Over time, new models become available, new releases show up, and this is one of the parts that allows, your control. You select what models you want, and you can decide what fits best on your devices too. So let's take a look. What I have here as a nice visual is Qwen 3.5, and this is a helpful model family to kind of pay attention to. If I go over to ollama.com, I can go over to the models page up at the top here, and I can scroll through all these different resources. Quen 3.5 is one of these model families, and this is a model provider from China. Alibaba is the company that makes the Quen models. And as we see here, they have a couple different sizes of models. Anytime you see like a number with the lowercase b or even uppercase b next to it, that's usually mentioning billions of parameters. So if we scroll down further, this kind of gives us the best view of what the model size is and then what it actually will look like as far as the size that is stored on your device or on the processor at one time. And so this allows us to really think about, how much storage, how much our processors can actually handle, and we can take a bit of a better look or a bit more of an informed look also by using this website. I reference this a lot because um, it is a website that kind of breaks down what you can run locally. This is called canirun.ai, and this website automatically finds what GPU you have on your device and then gives you a bit of a breakdown across all of these available Ollama models and says, this will take up, a certain percentage of your processing hardware. And generally, we can go down to the green section. Any of these spots that say, it's good processing, it only uses a certain percentage of our hardware. As we get into orange, we that's probably the upper limit of our processor, and we can then kind of give a good decision based off of that. So generally, what I'm seeing here and on my device is I start getting into the orange section around like 4 to 5 gigabytes of storage space. And that's generally a good way to think about it when we think about like the storage space on that GPU, to keep it most efficient, it needs to all fit on that processor. So like Quen 3.5, 4 billion parameters is just under 4 gigabytes. That ideally would make sense as a first try to run that model and see how fast it is, how intelligent it is, and then go from there. Maybe scale up if you want to try a bigger model and it might slow down your responses, or try a smaller model, might speed up your responses, but you might get less intelligent responses. So from there, you can really kind of figure out even across not just Quen 3.5, but any other model family and kind of see where the best bang for your buck or the best intelligence for the limited space on your device, um, which model fits the best category there. But as we're nearing the end of our session time here, I want to make sure we get into some of the demos that I have planned. So I switched it up, and this is basically what Ollama looks like out the gate. This is the chat application. When you install Ollama, you can open this up and just interact with models from the get-go. Looks very much like any chat application that you interact with, like ChatGPT. Generally, you have the model selector here, and this is a great way to pick out which model you want on your device. You can use that website to search through the different models that you want to find, and then you can even copy the model name, go over here, paste it in, and you see, we don't have this installed right now, but it's available to install, and interact with us. Now, I am going to pick a bit of a smaller model just to show what happens here. I'm actually going to use a Meta Llama model 3.23B as it's one that I don't have installed here. And I'm just going to say, hi, what's what's up, or something like random. This is just to show that in this chat app, if I select a model that I don't have installed, it gives me this nice installation breakdown. It updates me once it finally installs it, and then it immediately starts interacting with the prompt that I sent. So this can really allow you to, download Ollama, pick out what model you want, paste it into the model selector, and then just immediately start chatting with it. It's no other like clicks or no commands that you need to type in that are like very heavy code or anything like that. And in a second here, I think I've stalled enough. The response should pop up. And even to this point, the response showed up really fast. Don't know if you guys caught that, but like we'll see some examples here where the responses happen, and the timely nature, especially for local models, that responsiveness can be a big reason why you pick one over the other, especially if you're looking for that user experience, trying to get quicker responses and not being waiting forever. But let's look at some examples that I've done kind of in prep. So, I always like to prep some examples to make it a little easier. Demos are always good at kind of just failing when in the middle of recording sometimes. So this example is a good starting point. If I asked it a question to write me a summary for my monthly webinar and gave it some instruction, but not a whole lot, I get a decent output. It looks very much structurally like what you get out of ChatGPT or any of these state-of-the-art models, though the intelligence can be something you want to read through and just double check that it's following exactly what you ask. And even to this point, I think I want to emphasize another topic that we talked about, prompt engineering, and just say emphatically here, especially for local models, you need to prompt engineer a lot more than you need for these state-of-the-art models, especially when it comes down to giving relevant context and background information to guide the model exactly to the behavior that you want. So I asked a simple question. It was just a sentence long, and I got these bullet points. It didn't really kind of fit what I was thinking of as far as an expected output. So instead, I spent a little bit more time. I wrote out a longer prompt. Actually, some might say the prompt is longer than the output that I got here. But I think this illustrates an important part to that local AI mindset. In this case, what I would say, as I was focusing on different levels of quality, I get a whole lot better of an output with this prompting. Though I can see how you might think, well, if you spend all that time typing out this prompt and it's a lot longer, why would you do that instead of just write it out yourself? And again, I want to remind everyone, when we use local models, we want to be thinking about what tasks we can offload to local models to not always be reliant on cloud models, but also kind of automate out repetitive tasks. So this might be a lot of work just for one task. But let's say I have a prompt that I build out, and then I just swap in different inputs every time I do said task. I can have a lot longer of a prompt and then just kind of Mad Lib the prompt and kind of fill out the template with whatever relevant data at that point, at what I'm doing in the task is. And then, I'm still having such a long prompt, but it's more of just a template for me to do this repeatable task with local models. When I've tested and ensured that local models can handle this, and then I'm using the power of my device in a way that systematically will get me the same result and can save me time, money, and a lot of just worry, especially about data privacy. One thing that I want to get to here is a helpful breakdown of privacy aspects too. I was playing around with different demos here, and I found a relevant document here as an example to mention. This is a sample document over the internet that I've sourced, and this is an like an example of like an explanation of benefits. Things that are somewhat personal documents like these might be financial, might be healthcare, might be legal, any of these personal documents you might not want to share to these cloud models out there because anything you send out to the cloud is out in the internet. It might be stored on a server for 30 days after you prompt. It might be used in the training pipeline if you don't specifically go through your account settings on ChatGPT. All of these things can make a user, an individual, want to keep their data private, but also a bigger company as well. More and more, we got to think about how our data, especially when processing through these models, can stay in a private nature as well. So this is a good example where this is an actual explanation of benefits. There's some claims here. And again, this isn't anybody's details that I'm using. So this is purely just an example, a lot of, X'd out and fake data here. So I was able to, in the chat app, Ollama, I can click this plus button on the chat box, and that allows me to open up any file that I want on my device. So I uploaded this PDF, and I basically asked it, based on the attached document, can you break down these three claims and list if there's any alerts? Just trying to understand if it can read the document and give me a bit more of like a human explanation to sometimes harder to understand documents like medical, financial, or legal things. And so, yeah, this model, I used the Llama 3.21b, which is a 1 billion parameter model, and it is a bit older nowadays than the more recent models. So it did struggle here. If I'm not going to fact check it and show you guys every little bit here on the meeting, but generally these numbers are incorrect. And I think this also emphasizes something that, when you're using local models, you do have to test. You do have to double check the numbers and be a little bit more critical. But once you get a setting where you feel a lot more comfortable within that, here I switched this to a different model, DeepSeek R1, which is a popular reasoning model. In the previous monthly webinar session, we talked about reasoning and why that's so important. This model is a little bit bigger too, and a little bit more up to date. It was able to read the document and get all of this information correct. It even explained an alert exactly how I asked and kind of made these things a little bit more attainable to somebody who might not understand exactly what the original document was explaining. So This, I think, is the real benefit in today's age. The cost analysis might be still really hard to have, as there's huge uh, influx of pricing on the GPUs and storage out there nowadays, especially RAM prices and things of that nature. All of those are affected because of AI. But in that realm, we can have local setups doing the simple tasks, doing things that are a bit more private for us, and still get that same level of intelligence with just a little bit more hands-on work at the start. So I think this is generally a good point to kind of wrap up at this point and really just emphasize that these models are powerful, but it's a balance approach that we always need to have. And generally, it's not that we're replacing cloud models, we're just taking away the bottom barrier to entry with using AI models in offline or private scenarios. So thank you guys for being a great group of attendees. I'm happy to continue talking with you guys. And if there's any questions about any courses or anything that we provide, we can definitely chat more. But that's it from us, and have a good rest of your day.